Okay, so today I am going to show how we are using the software R to solve the problem that I mentioned in my last video. So here is the problem that I had. So I had this system, this approximate linear system. The first column was 342, the second column was 413, and the measurement vector was 9.8, 9.1, then 7.0. So in order to solve it using R, or let's start R first. I am using Ubuntu. So I am starting it from the command line. You might be using some other thing. If you are using Windows, you might be double clicking some R icon or starting from R Studio. So personally, I prefer to use just plain R instead of R Studio. So the first thing that I will do is to create the coefficient matrix. So let me call that X. So X is matrix. I have to enter it column by column. So I will create the matrix C 3 4 2 4 1 3. The C that I have written, that means you create a vector. So you just create a vector of these numbers. So that's what I am showing. Oops, what am I doing? So I am just creating a vector of these numbers, and I have specified all the numbers column by column. So 3 first, then 4, then 2, then 4, then 1, then 3. Now I have to wrap all these things up in a matrix. I will specify the number of rows, that is 3, and number of columns, that is 2. And that will give me my X. Let's see. X, enter. That is indeed 3, 4, 2, 4, 1, 3. These are the row numbers and these are the column numbers. And then what I will do is I will create this measurement vector. I will call that Y. Now I do not need the matrix command, just this C will do 9.1, 7.0, and that is my Y. Now I am going to create this model, and the way to create that model is somewhat strange. I will have to start with the measurement vector, that is Y, and then I will have to put a tilde. This tilde basically stands for this approximate equality. Then I will have to write X. So that is, roughly speaking, this particular model. So this is the right hand, this is the measurement vector, not the right hand vector. In this case I am writing in the left hand. That's always the rule. You first start with the measurement vector, then the approximate equality represented by tilde, then the coefficient matrix. There are other ways of writing it also. We are going to see that, but this is the simplest form. And I am going to solve it as a linear model. So I will write LN, that stands for linear model. Now comes the weird part. I have to write a -1 after this. I will explain the -1 in a moment. Now this is the command. I will hit enter and I will get the values. X1 2.0378 and X2 0.9411. What this means is that it has estimated in the least squares way the value of A and the value of B. So A turns out to be 2.0378 and B turns out to be 0.9411. That's it. Now I will explain why I needed that -1. So what it does, that is not very difficult to see. I will just store this result in something called a variable fit. So I just created a variable called fit and stored the result of ln inside that variable. Now I will see what is the coefficient matrix that fit used. The command for that is model.matrix. And model.matrix is indeed the matrix that we had given. Ignore for the time being those ATTR, assign, etc. So it is 3, 4, 2, 4, 1, 3 as it should have been. Now let us see what it would have been had I not used that -1. So I will replay that command. In order to replay the command, I will not type everything but simply press the upward cursor key of my keyboard to get the last command that I printed. Press it again and I will get to the command before that, and I will remove that X. Let's give it a different name, phi2. I will again go through that model matrix line, and you will see in this case the matrix is different. It is basically the same as before. We do have the 3, 4 and 4, 1 and 2, 3, but it has appended one additional column of 1 at the beginning. And that is a habit of R which might appear to be weird at present, but once we learn a little bit more of linear model, we will see that this is actually a helpful behavior, that R will by default append a column of 1 in front of the matrix which you specify. In order to prevent R from doing that, we have to put that -1. Now look carefully at this formula object. Such a thing is called a formula in R. X minus 1 actually has a very special meaning. It does not mean subtract 1 from each entry of the matrix as we might have expected. This means that do not append an additional column of 1. So whenever you are writing a formula object, remember that the traditional arithmetic operators do not have their usual meaning after that tilde notation. We are going to learn later about the details, about the syntax of this formula object in greater details, but for the time being, just enough to know that if you have the measurement vector and if you are ready to specify the entire coefficient matrix, then you can always use the lm function in this way to solve the least squares problem.